Hey guys, the point of this video that you guys are looking at today is to help you review for the test that we're going to have this week. And I promise you we're going to have a test this week. I know we've been pushing it back and pushing it back, but you got a test this week. You watch this video, you'll be ready to take the test. So we got a lot to cover on this test, but the first thing we're going to do is solving equations, and we're going to jump right in with solving multi-step equations. So multi-step equations are going to have like distributing in them, combining like terms, and then once you've done all that, you still got to solve the equation. But I made a list here of all the steps you got to follow, and if you follow these steps, you should be able to solve any multi-step equation. So the first thing you're going to do is distribute whenever you can. If you see parentheses, that means distribute. Second, you want to look at both sides of the equation and see if there's any like terms you can combine. Once you've done that, it's basically like solving a regular two-step equation. You're going to use inverse operations to isolate the variable. And usually you want to get, not usually, but always you want to get the variables to one side. Variables are like your x term or your v terms. Get all those to one side, and then you want to get all the constants, which are like your numbers, to the other side. And then you just use inverse operations to get the variable by itself. So let's take a look at this one. We have negative 12 equals 2 plus 5v plus 2v. So let's think. What's the first thing you can do in this equation? Well, there are no parentheses, so there's going to be no distributing. So we're going to move right to step 2, which is combine like terms. Are there any like terms we can combine? And if you look over here, you have 5v plus 2v. Those are like terms. 5v and 2v are like terms. So we can combine those, and they become positive 7v. And everything else stays the same. So you have negative 12 equals 2 plus 7v. All we did was combine the 5v and the 2v. So now we want to try to get the variables on one side and the constants on the other side. 7v is fine, but I don't want this 2 here because that's a constant, so I want it over here with this negative 12. So you got to think, use the inverse operation. You can't see it, but that's a positive 2. So how do we get rid of a positive 2? Meaning, what's the inverse of plus 2? And the inverse of plus 2 is minus 2. So we subtract 2 from both sides. You kind of imagine there's like a line down the middle there. Well, negative 12 minus 2 is negative 14. The positive 2 and the negative 2 cancel out, so you get negative 14 equals 7v. And once you're set up like this, it's easy to solve because all you got to think is, I want to get v by itself. I want to isolate v. But right now I have 7 times v. So you're multiplying v by 7. So think, what's the inverse of multiplying by 7? The inverse of multiplying by 7 is dividing by 7. But of course, if you divide that side by 7, you got to divide that side by 7. So you get v equals, you can do this in your calculator, but a negative divided by a positive is a negative, and 14 divided by 7 is 2. And that's your answer. V equals negative 2. Now, I'm going to leave it up to you guys to check this, but the answer for this one equation is v equals negative 2. Okay, let's try another one. Now, before we get started, I just want to point out that I realized I made a slight typo here, which says, it says move variable to one side. It should really say move variable terms to the other side, but okay, we're not going to worry about that. So you want to move variable terms to one side, and then you want to move constant terms to the other side. All right, so take a look at this one. What's the first thing you can do in this equation that we want to solve? So unlike the last one, this one you see it does have parentheses, which means we can do the distributive property. So we want to distribute this 2 to the 5k and then distribute the 2 to the negative 6. So I'm going to leave the 4k alone. That doesn't change. But we have positive 2 times 5k. So positive 2 times 5k is positive 10k. And positive 2 times negative 6, a positive times a negative is a negative, so we get negative 12. And then on this side, we get negative 3k minus 39. Well, that side just basically stays the same. Okay, now what can we do? On this side, we have like terms, 10k and negative 4k. So what's 10k minus 4k? 6k, I'm just combining those, minus 12 equals negative 3k minus 39. This side I haven't touched yet. So now we want to move all the variable terms to one side. And what I like to do is, let's see here. I want to look for the smaller of the two. This just is with the variable terms, but we have negative 3k and we have 6k. Which one's smaller? Or lesser, I guess. The lesser one is negative 3k. So I'm going to deal with this one. I want to move this negative, I want to get rid of this negative 3k on this side. So how do I get rid of negative 3k? I add 3k. But of course, if I add 3k on this side of the equal sign, I also have to add 3k on this side of the equal sign. Oops. So now we have 6k plus 3k is 9k minus 12. The negative 3k and the positive 3k cancel out, equals negative 39. And now I want to get the constants, meaning this negative 12, to the other side. How do I get rid of negative 12? I add 12. So I add 12 here. I add 12 here. The negative 12 and the positive 12 cancel out, so I get 9k equals negative 39 plus 12 is negative 27. So basically, I've reduced this whole equation to 9k equals negative 27. Well, now what? I want to get k by itself. This is 9 times k. What's the inverse operation of multiplying by 9? Dividing by 9. You divide this side by 9, you divide this side by 9, and you get k equals negative 3. Okay, so now we're going to move on to graphing equations. So we have this equation here, y equals 3 over 2x plus 1. So my first question for you guys is, which of these numbers represents the y-intercept? So which of these numbers that you see represents the value where the graph crosses the y-axis? Okay, so we see two numbers here. We see 3 over 2, and we see 1. So which one is the y-intercept? And that's actually this number over here. The 1 is the y-intercept, and this 3 over 2 is the slope. So if we went over to our graph here, this is the x-axis, and this is the y-axis. So I like to start with the y-intercept. The y-intercept is positive 1. So we go to our y-axis, and we go to positive 1, which is right here. And I'm going to put a dot there because this graph crosses the y-axis at positive 1. Then the slope is 3 over 2. So what does slope mean? So slope, sometimes we say it's like y2 minus y1 over x2 minus x1. But really what that means is it's the change in y over the change in x. So the top number tells you how much the y value changes, and y goes up and down. And the bottom number tells you how much the x value changes, and x goes left and right. So the top number says 3, positive 3. That means we go up from this point, 1, 2, 3. And the bottom number 2 says we go over 1, 2. So we put a dot right there. And that's the line. You might also think, by the way, like we also have to have this point on the line too. And why is that? Because if the slope is 3 over 2, that means from this point we go up 1, 2, 3, and over 2. But anyway, you connect these with a line. I'm going to do my best at it. Okay, that was pretty close. And it should go through that dot, but whatever. That's the line. Y equals 3 over 2x plus 1. Okay, so what if you want to find the slope of a line when you're given a graph? So what you should do in this case is find points on the graph. You need at least 2 points. It doesn't really matter which 2 points, but what you should do is find 2 points that are like nice and evenly on these grid lines. So like, let's say we picked this one right here and this one right here. So remember from our last question that we said slope is the change in y over the change in x. And sometimes we see that as y2 minus y1 over x2 minus x1. But we don't need to use that right now because we have a graph. Okay, so from this point to this point, on our y-axis, this is the x-axis and this is the y-axis. So on our y-axis, going up and down, we go down 1 and over 2. So what's the slope of this line? Because we go down 1, I'm going to write -1. And because we go to the right 2, I'm going to write +2. So the slope of this line, which I guess is m, equals -1 over 2. Down 1 over 2. Okay, now let's say we had one like this, where they're not just asking you what's the slope, but what's the equation. So when you want to find the equation of a line, usually we want to write it in the format of y equals mx plus b. And what do these numbers mean? So the b value is the y-intercept, and the m value is the slope. Okay, so first things first, let's look at the y-intercept. Where does this graph cross the y-axis? This is x, and this is the y-axis. So we have x and y. Where does this graph cross the y-axis? This graph crosses the y-axis at -2. So we know this value at the end is going to be -2. It crosses the y-axis here at -2. Now all we have left to do is find out the slope. So I'm going to start with this point, and I'm going to pick this point over here. Although you could really pick any point, but these two will work just fine. So from here to here, from this point to this point, we go up 3 and over 2. Up 3 and over 2. So we have change in y, change in x. How much does this graph change in on the y-axis? 3. How much does this graph change left to right on the x-axis? 2. And we're just following this format. Y equals m, this is the slope, plus x minus b. And the y-intercept is -2. So the equation of this line is y equals 3 over 2x minus 2. Okay, so in this problem, we're going to have to graph a real-world situation. Actually, we're going to have to graph 2 real-world situations. So let's take a look at this. It says, Ms. Bice and Mr. Holland are taking college classes to become principals of the school. Ms. Bice has completed 12 credits and earns 6 credits per semester. Mr. Holland hasn't completed any credits yet, but he earns 9 credits per semester. So we're going to let x equal the number of semesters and let y equal the number of credits. Graph these two situations and which graph represents the proportion. So something to think about already is which of these two situations represents a proportion. Okay, let's graph these. So this down here is our x-axis, and this going up and down is our y-axis. And you'll notice that this is only positive x values because you can't go, this is going to be per semester. So you can't really go backwards in time per semester. And the y-axis is also positive because you can't ever have negative credits. The lowest number of credits you could ever have is 0. So the x-axis is going to be the number of semesters. So let's make the x-axis be 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, I don't think we're going to get that far. And then on the y-axis, if I'm looking at these numbers here, it's like 6, 9, 12. So let's let the number of credits be multiples of 3. So this will be 0, then 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Okay, my graph isn't so beautiful, but I think it'll get the point across. Okay, so let's do Miss Bice first. Miss Bice has already completed 12 credits. So just going in, when the number of semesters is 0, let's do Miss Bice in blue. So just going in, when Miss Bice starts, she already has 12 credits. And actually, before I do that though, let me make this will be semesters, and this will be credits. Okay, so Miss Bice already has 12 credits. So before she's even done one semester of coursework, she already has 12 credits. So for 0 semesters, I'm going to put a dot at 12 on the y-axis, which represents the number of credits. And then she earns 6 credits per semester. So after one semester, remember she already has 12, after one semester, she's going to have 18 credits. Why is that? Well, because she started at 12, and then after one semester, she goes up by 6. So now she's going to have 18. Then after another semester, she's going to have 24. Again, we're going up by 6. And then she's going to have 30 and 36. And that's basically where this graph ends up. Oh, that line was terrible, but okay. It's supposed to go through these dots, but whatever. Now let's do Mr. Holland, and he'll be in red. So Mr. Holland hasn't completed any credits yet. So when the semester starts, he's at 0. So we'll put a dot here at 0. But he earns 9 credits per semester. So after one semester, he's going to have 9 credits. Then after 2 semesters, he's going to have 18. Then after 3 semesters, he's going to have 27. I'm just going up by 9 every time. And then after 4 semesters, he's going to have 36. So Mr. Holland looks like that. Okay, those graphs, those lines aren't exactly perfect, but you get the idea. And really importantly is which graph represents a proportion. So which of these two represents a proportion? Well, it turns out that Mr. Holland represents a proportion because he started at 0. Any proportion that you graph like this, a line that's a proportion, is going to go through the point 0, 0. And we call this point the origin. So anytime you see a linear graph that's a proportion, it has to go through the point 0, 0, which we also call the origin.